Hello, I am David W. Parker. This is Programming Today I Learned 3D Math Series, Episode 4, Part 4 of looking at vectors. Today we'll be looking at the dot product and how to project onto a matrix and what that is. So the vector dot product is basically it's one form of multiplying a vector by a vector, and it's also known as the inner product. It's performed before addition and subtraction, and it is denoted by a little dot, thus the dot product. A dot product is basically the sum of the products of the corresponding components. So this A dot B is going to have A times B plus A2 B2 plus dot 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 until you get down to AN plus times BN is the last element. So what does this look like? This is basically the same thing as a summation of all of the elements multiplied together. So in 2D, there's AX BX plus AY BY, and 3D, ax bx plus ay by plus az bz, and obviously this is going to yield a single scalar. It is commutative, so a dot b is equal to b dot a, and so if we have an example here, you could see 23 dot 4 negative 2 is the same thing as 4 negative 2 dot 23. The dot product geometrically is basically the same thing as it's related to different angles between two vectors. It is equal to the product of the magnitudes of those vectors and the cosine of the angle between them. So a dot b is equal to the magnitude of a times the magnitude of b times the cosine of the angle which is between them. Geometrically, you could solve for the angle, so the a cosine a dot b over the magnitudes of each. Thinking about these two here, if we took the unit vector of each, those will be 1, so we don't have to do any division. So we can make sure we're using unit vectors here to solve for that. And if we don't need the exact value of theta, we just want the relative orientation, we can just use the sign of the dot product. And here's some different examples of what ends up happening. So if a dot b is greater than 0, that means the angle is between 0 and 90. It's acute, obviously. It's between 0 and 90. And then A and B are pointing in the same direction. If it's A dot B is equal to 0, then this should say that is equal to 90. That's an errata, excuse me. So it's a right angle. The angle will be 90. And A dot and B are perpendicular. A dot B is less than 0. Then we're between 90 and 100, and the angle is obtuse, and they're pointing in opposite directions, or yeah, opposite directions. Then that's mean like a perpendicular, parallel opposite, and parallel the same, just in the general acute and obtuse sense from geometry. And note if either A or B are 0, then the result will also be 0. So the 0 vector is perpendicular to every other element, a vector, excuse me. And projection is basically when you have two vectors v and u, and there exists a v double parallel or v perpendicular or q that are parallel and perpendicular to u, and we can compute these by using the dot product. So here's an example of what that v and u looks like. So we have this vector here of v and a short vector here of u. So there's a vector p and q, one that is parallel to u, one that is perpendicular to u, that will end up being this v vector. So you could see the projection here. V parallel is going to be equal to the u vector times the magnitude of v parallel times the magnitude of u. Using some trigonometry, we can change this around to cosine of theta times the parallel, or excuse me, times the magnitude of v is equal to the magnitude of v parallel. And so using the projection, substituting from slide 5, spell substituting wrong again, we can substitute this whole thing and basically solve down to what this equation is here for the parallel is u times v dot u over the magnitude of u squared. Once we have that, we're able to solve the perpendicular v, and basically v perpendicular plus v parallel is equal to v. So we know the perpendicular is v minus v parallel, so we know that it is v minus the previous equation. So that's it for this episode. It's kind of quick. It's a lot to take in. I didn't show you exact examples, but you can go out on the internets and look them up if you so choose. The dot product is useful to know about and kind of understand what it's doing. So as our projections, we'll be using them later as well. So if you like what you saw today, go ahead and subscribe and give a like. Share this on social media if you will, and go to ProgrammingTIL and sign up for my newsletter. Have a great one. Thanks.